In this video, I'm going to go over the logic of ANOVA. It's a little bit different than the logic of the t-test that we've been doing, but basically we're still looking for mean differences between groups. This time it's 3 or more groups. But in order to evaluate those mean differences, we're using variance. And we're using 2 different kinds of variance. We're using the variance that happens within a sample and the variance that happens between samples. Let's take a look. So we're going to talk about how variance is different between and within, and also how these 2 types of variance form the ratio that creates the F-score that we talked about. All right, so there are 2 steps in conducting an ANOVA. The first step is to figure the total variance, all the different ways that scores vary between the groups, within the groups, all the things that make the scores different. And then the second thing we do is we separate the variance into 2 different parts. So, first step, find the total variability, the total variance for the entire set of data. We do this in a certain way that I'll explain later. And then this really combines all the scores from all the separate samples. We're finding out all the variability combined. Step 2 is to separate this total variability into 2 separate components. The first component is called between treatment variance. This is the variance between the groups. And then we have something called within treatment variance. This is the variance you see within each individual group. So between treatments variability, we call this the mean squares between. That's the verbiage that we're going to use. And this is the notation that we're going to use for mean squares between. And this is going to measure the size of the differences between the sample means. So we have 3 different groups, for example, and there's going to be a variance of the mean of group 1 and the mean of group 2 and the mean of group 3. Those scores are not likely to be equal. There's going to be some variance. And we're going to measure that with the mean squares between. So this is just an example. We have 3 different groups and they're all different and they have variance between the 3 different groups. This is between group variance. Between treatments variability has 2 sources. First of all, we have what we call systematic differences. And this means that the independent variable has caused some sort of variability between these 3 groups. So something about what we did as researchers, we put people into these different groups, we manipulated an independent variable, and that causes the groups to be different. So that's one source of between treatments variability. And another source of between treatments variability is there's an element of randomness. There are individual differences that people bring to the experimental situation. Just some random error that's along with these systematic differences that are due to the independent variable. That randomness error is experimental error, and like I said, we attribute it to some individual differences that people bring to the research situation. Within treatments variability, we're going to call this mean squares within, and it looks like this, MS with the subscript within. And it measures differences that are inside each sample. So this within difference variability is really the difference between the people in the sample. And it really determines the randomness or the error variance because people come to a situation differently, but everybody in, for example, group A is getting the same treatment. So whatever variability is between those scores doesn't have to do with the treatment, it has to do with the people in the study. So here's an example. We have 3 different groups and there are 4 people in each group. And what within treatments variance looks at is how is Anne different from Bill and different from Charlie and Diane? How are these scores varying? Now again, between variance looks at the difference between the means of these groups, but within looks at the difference in the variance within the group itself. So within treatment variance, if everyone gets the same treatment, then any differences can't be because of the treatment. That's just weird error variance. It measures naturally occurring differences that exist when there is no treatment effect whatsoever. That's within treatment variance. So we've given a brief overview to what is between treatment variance and within treatment variance. And in the next video, we're going to put it all together to see how we come up with an F score.